Hi, everyone. This is a presentation on ResilientDB and ResView. What is the application, how to make use of it, and why you should use it. So, just getting started, we're going to give a brief overview of what is ResilientDB as context for this project. So what is ResilientDB? ResilientDB is a high-throughput yielding permission blockchain fabric founded by Expo Lab at UC Davis in 2018. It is now currently partnered with Apache in the Apache Incubation Program. So what does that actually mean? Well, it's essentially a couple of different things, but let me break it down. So ResilientDB is a permission blockchain system, meaning that it's a database which makes use of permission blockchain. So why is permission blockchain important? Well, permission blockchain essentially makes it so you're able to have more secure transactions. It's harder for transactions that are malicious to get through, and it prevents the database from getting hacked, as even if one replica goes down, the other ones are able to keep it secure. There are also multiple replicas to ensure uptime, which means that if something ever goes wrong with one of the replicas, you're not just locked out from the data. You're able to access another replica and get that same exact data that you need. So it's going to ensure uptime. And even if a replica goes faulty, so somebody hacks it, you're going to be able to preserve your data and make sure that nothing goes wrong. Finally, it supports primary backup architecture, which means that any replica can become the primary and initiate transactions, while backups agree to follow a non-morose primary. So what does this mean? It essentially means that there's no leader in ResilientDB. It means that even if the primary is taken over, they can all the replicas can just swap to a new primary and keep conducting transactions. So it makes it a lot harder for malicious actors to get access to the system, and it just in general makes it more secure. So now that we know what ResilientDB is, why was ResView devised in the first place? What was the core concept behind it? Well, this is essentially our problem statement. The average user of the blockchain system does not understand what is happening after they send their transaction. Numerous users that we asked did not know the difference between the blockchain system and a normal database system when they were sending transactions. From their perspective, all that was happening was that they were just sending the transaction to the backend and it was getting handled. Even for developers on ResilientDB, it was difficult for them to understand what was happening at the low levels of the blockchain system. How are the different replicas communicating with each other? What was actually being sent between the different replicas, etc. At the individual replica level itself, also, it was very hard to see what was happening. In order to basically look at what was happening on the replica level, you had to delve into the logs and read them line by line to understand what was even happening in a replica. If I wanted to test a blockchain system and see what would happen with replica 1, for instance, versus replica 2, there was no easy way to compare them. I would have to actually just look through the log file and then see which lines are different between them. Finally, it was difficult to see what happened when a replica was faulty and how it affected the PBFT consensus protocol. And the reason why this is important is twofold. One, it was very difficult to actually make replicas faulty. The only way to do so was to essentially set a replica to faulty beforehand and then load the instance that way. There was no dynamic way to do so. Secondly, when a replica was faulty, it was very difficult to tell if it was even faulty or what did it mean for it to be faulty. There was no easy way to check it. You had to go into the log files and actually check. So how did previous solutions handle this? Well, previous solutions handled some of these issues and didn't handle other ones. So one previous solution was Pretty PBFT, which essentially hard-coded diagrams to display consensus. What does this mean? So to actually view what was happening with the ResilientDB backend, they created diagrams that showed what was happening, but it wasn't real-time diagram production. This means that users weren't actually seeing what was happening with their transactions in the backend whenever they sent it. They were just seeing what happened with generic transactions in the backend of PBFT. We found that this is a big hole in the current architecture of ResilientDB, and so we sought to fill it out. Similarly, there was no solution that existed which gathered data from ResilientDB nodes to see what was happening at a transaction level. There were solutions to basically view it as a overview of all the transactions, such as Grafana, where you could see how many messages were collected total, how many transactions were done total. But to view an individual transaction, there was actually no way to do so. You could just compare between before the transaction was sent and after the transaction was sent in the cumulative data collection. And finally, the only way to actually send transactions to the backend was either you had to make a front-end application and then send API calls, or you would have to go into the terminal of the ResilientDB service itself and then send the transactions that way. This is all very clunky, and it was just very tedious to do so and test the ResilientDB service. So we sought to essentially solve this problem by creating a new application known as ResView. But what is ResView? Well, ResView is an application designed to observe the progression of the ResilientDB service as it processes transactions, meaning when you send a transaction to the backend, what's actually happening with it. It's also an interface to interact with ResilientDB in different scenarios and edge cases, meaning that you're able to actually send transactions to the backend and modify what's happening with the replicas in order to basically test out different edge cases. So what happens when all the replicas are faulty? What happens when most of the replicas are faulty? What happens when none of the replicas are faulty? Stuff like that. Finally, it's a service to monitor transaction history and the ResilientDB status. So essentially, if you wanted to look at all the transactions that were sent over the past day, for instance, you're able to do so with ResView. And secondarily, you're able to see what is the status of the various replicas in ResilientDB. So what are you able to do as a user on ResilientDB or ResView? So you're able to send transactions, view past transactions and their progression, test transactions with faulty replicas. You're able to force view changes by making a majority of the replicas faulty. You're able to view transactions from other applications. So let's say that I essentially made a new front-end application that makes use of ResilientDB. If I sent a transaction from that application, I would actually be able to see that transaction in ResView. And finally, you're able to view the status of replicas, so they're faulty or not, and also compare their efficiency. So you can see, all right, how did replicas 1 and 2 compare to replicas 3 and 4 when it comes to sending out and receiving messages? How did we build ResView? Well, ResView was built primarily in the front end. It's built on React.js using D3 and Nevo graphs for visualization. In order to collect data from the backend, we use WebSockets to send transactions and receive data. And finally, we make use of Tailwind for our general application design. On the backend, there are a couple of components. So when we're sending our transactions, we're hitting a Python SDK, which is essentially serving as our API endpoint. ResilientDB is running on C++. We modified ResilientDB a bit so we could actually do this data collection and data transfer. So we're running on a specially modified version of it. Finally, we have a Crow and GraphQL server, which serves as an intermediary for transactions, meaning that whenever you send a transaction to this GraphQL or Crow server, it's going to basically forward it to the ResilientDB service to be processed. What happens in the actual ResView workflow? So from beginning to end, what happens? Well, first off, there's a number of settings that you can implement or you can set with ResView before you even send a transaction. You can set replica 1 or replica 2 to faulty. You can you can basically set what is the key value pair that you're going to send. But in general, all the ResView work starts with when a transaction is sent. So regardless of if ResView is sending it or a client application is sending it, it's transaction is going to hit GraphQL through Crow, and then it's going to be forwarded to ResilientDB. So GraphQL is essentially going to receive the transactions from a client, transform them into a request suitable for ResilientDB, and then send it to the ResilientDB service. ResilientDB will essentially process the transaction, meaning that it will run the PBFT consensus protocol on it, and then it will execute the transaction. As this is being done, the consensus data is going to be collected in ResilientDB, and once the transaction either succeeds or fails, it's going to essentially send the consensus data up to ResView. Finally, ResView is going to receive the data from each replica and then store it. So we're going to collect all of the data simultaneously. The data is going to be then transformed and displayed in the PBFT diagram and message versus time graphs for the user to essentially observe and draw conclusions from. So now that you understand what is ResView, I'm going to give a brief demo of just how to use it and what are the different components in it. So there are two ways to access ResView. So the first way to access ResView is you make use of this resview.resilientdb.com. This is a browser-hosted version of ResView. You don't need to have the front end downloaded. You can just load this URL and you're going to have access to it. The other way that you can load ResView is you download our front end application and then run it on localhost 3000, and you will similarly get the ResView application. So to start off with, you're going to have our homepage. This is essentially going to just go over the different components of ResilientDB. So PBFT, for instance, the different phases of PBFT, what are the different graphs that we're showing on our ResView service, and then the different toggles that you have while doing ResView. So to start off with, here's our dashboard. So let me just quickly go over what are the different elements of this dashboard. To start off with, here on the left, we have the replica status. So these are the different statuses of the replicas. We have 4 replicas on the backend currently, and you can see that all the replicas are currently active and functioning as they should be. Next, you can see we have our PBFT graph. Even if you haven't sent any transactions to the backend, we provide sample transactions that users can basically overview and see what is the expected behavior on this. So for instance, this default transaction, it has replica 2 as the primary and replica 3 as faulty. And you can see that this graph is right here. If you want to, you can essentially replay it from the beginning and see how the messages are goes through the flow. So it goes from the client to the primary sends it out to all the other replicas. They're going to communicate with each other and then reply to the client. But because replica 3 is faulty, it's not able to either receive the messages or send out the messages because it doesn't know there's a message. And so no messages actually come out from replica 3. So we have 6 sample transactions here that you can essentially view. Next, we have the prepare messages versus time and commit messages versus time. So these are the messages collected in the prepare phase and the commit phase respectively, and essentially are how the different replicas communicate with each other. Because replica 3 is faulty, there's actually no message collection done by it because it doesn't even know that it's getting messages. It's not able to receive any. But you can see with the other 3 replicas, they're all able to collect messages, and you can see the speed at which they did so. So you can see that replica 4 actually took the longest on the first message, but then it collected the rest very quickly after. So here we have a toggle for faultiness, which I'll go over later, and how to send the transactions to the backend. I'll go over this when I'm demonstrating how to actually make use of this application to send your own transactions. Finally, we have a table down here, which is essentially going to have data from each of the transactions. So the different times of each of the replicas collected messages, and then just what the primary is and how many faulty replicas were in the transaction. Now, how would you send your own transactions? Or to be more clear, how do you basically observe your own transactions? So you're going to need 2 things before you can do that. The first thing you're going to need is you're going to need to run 2 things on the backend. You're going to need to run the ResilientDB service on the backend by running this /service/tools kv/server-tools/start-kv-service.sh. When you do so, it's going to load up the ResilientDB service. Secondarily, you're going to need to run the GraphQL and Crow server on this backend. So when you do so, it'll basically start receiving, it'll be able to receive transactions. You'll know that this is done because you'll essentially see these replica statuses as being green here when the ResilientDB service is running. Next, let's send a transaction. So I'm just going to send a basic key1, value1 transaction, and I'm going to commit it to the backend. So if I go to my ResilientDB here, you can see that it's going to receive the transaction, and it's going to be being processed by the backend. And as you can see, we have the transaction right here. So as this is in the default state of the backend, replica 1 is the primary. It's going to send out the transactions to the other replicas. They're going to communicate with each other in the prepare and commit phase, and then we're going to get the reply here now that all the replicas have done so. And this is the perfectly normal graph for when replica 1 is the primary and there's no faulty nodes. And this is what actually happens on the backend. You can see if we looked into the log files of the backend, for instance, you can see that we have the transaction data being collected on the backend, and it's going to be sent to the front end. So let's test a different scenario. So let's say we want to test what happens when replica 2 is faulty and the other replicas are all normal. So I can click this button and it's going to make replica 2 faulty. As you can see here on the left, replica 2 is now faulty as a result of this. And now let's send a get transaction to the backend. So I'm going to send get. And if I go to my GraphQL, you can see that now we sent a get transaction here. And if I go up here, we just sent a new transaction. And now if I go here to this, you can see replica 1 is the primary, replica 2 is faulty, and these are the actual messages that are being sent between the replicas. So replica 2 was not able to receive any other messages, and therefore was not able to send anything else out. As you can see here, we have the prepare and commit messages for this graph. You can expand these out to actually view them in more detail if you wish to do so. But let's say that now that I've done this transaction, I want to see what happened with the previous transaction. So I wanted to see what happens with the perfectly normal transaction for compare and contrast. I can actually just click the transaction right here. And now I'm able to see what happened with the transaction previously. I'm able to see the graphs for the transaction, and I'm able to just basically go back and forth between them. If I go down here to the table, I can see all the data for these 2 transactions that I sent. So how did it go with all the replicas? What were the different times that it took for each of the phases and such and such. So yeah, and if I wanted to basically turn replica 2 back on, I essentially just click this, and replica 2 should now be no longer faulty. So these are a couple of the different tools that you're going to want to make use of for ResilientDB and when you're working with ResilientDB. So if new users wanted to basically develop their own front-end application, whenever they send a transaction to the backend, you're able to see it all on this PBFT graph, prepare messages versus time graph, and commit messages versus time graph. If you made a modification to the backend and you want to send transactions to make sure that it actually functions on the backend, you're able to send transactions from here and test different edge cases, such as what happens when one of the replicas is faulty, what happens when we have different primaries, and you're able to actually see what happens on the back end. Overall, this tool is very helpful for any developers working with ResilientDB, as they just get a lot more insight into what's happening and essentially just test it out. It's a sandbox where you can see, in this case, what does ResilientDB do? In this case, what does ResilientDB do? Already, we have students making use of this service to basically learn about ResilientDB and blockchain systems and help develop their own applications on top of it. I hope that this demo or presentation and demo have given you a greater insight into ResView and that you can start leveraging it when developing your own applications or additions to ResilientDB in the backend in the future. Thank you.